By the circadian rhythms, take the strongest cue from our environment by tracking when it is light and darkness. And the best organ in our body that senses this light are the eyes. Almost 25 years ago, scientists figured out that there is not only one master clock in the brain, actually clocks are present in every cell, in every organ, even on our skin, even in the hair follicle. Everything has clocks. In the morning, just getting out, particularly when you are flying into a new time zone, then it's very effective. Even I do it. I wake up and the first thing that I do is go for a walk or go for just a slow jog outdoor for 30 minutes to 45 minutes. And that activity, physical activity, along with this light just increase my energy level and I can readjust to the new time zone much faster.
Howdy friends. In today's conversation, we welcome back Satchin Panda, PhD. Dr. Panda is a professor at the Salk Institute in California, and his lab studies how circadian rhythms influence metabolic health and longevity. In this exchange, we revisit some of the most important circadian biology principles that we previously discussed together back in episode 221, and we also explore a few new concepts too. You'll learn about how circadian rhythms affect your physiology, what circadian disruption is, how circadian disruption could be affecting your health, and what the leading causes of circadian disruption are. And then next week, Dr. Panda returns to walk us through the 6 lifestyle habits that are critical to supporting circadian biology and optimizing your health. I hope you find it interesting and enjoyable. And with that, this is me and Satchin Panda, PhD.
To kick things off, perhaps you could remind all of us, what are circadian rhythms and why should we care about them if we're interested in living a long, healthy life?
Well, circadian rhythms are daily timetables of everything that goes on in our body. So for example, every hormone, every digestive juice, every brain chemical, neurotransmitter, and even every gene in our genome is programmed to rise and fall at specific time of the day or night. And these timely activities of our genome and our hormones and everything helps us to stay resilient and prevents disease. And when we have strong circadian rhythm, even if we fall sick, then it accelerates cure and we can get back to full functionality much quicker. And this is not only one type of disease, they affect almost all aspects of health. Infectious disease, metabolic disease, brain affective disorders, so depression, anxiety, etc., and also injuries and recovery from injuries. And since the reason why we can't live longer and live a healthy life too long is because we fall sick to any one of these 4 diseases. That's why circadian rhythms are very important starting from newborn until we are 100 years old.
Do all living organisms have a circadian rhythm?
Yes, almost all living organisms except some bacteria and viruses. Everyone has circadian rhythm. The reason is all life forms on our planet evolved under roughly 24 hours light dark cycle. And that's why there is strong rhythm in light and darkness. There is rhythm in humidity. There is rhythm in temperature, and we all have to adapt. So that's why all organisms have circadian rhythms.
And so as I understand it, these rhythms, whether we're talking about heart rate or blood pressure fluctuations throughout the day, these are controlled by local mechanisms, but also central mechanisms or a master clock that we've spoken about before. Perhaps you could explain the significance of there being a kind of central master clock in the brain and then these peripheral clocks that all kind of work together.
Yeah, so as we just discussed, since all life forms, including us humans, we evolved on this planet. And there is one thing that is constant that has happened over the last 200,000 years. That is, every day sun came up and then at the evening it went down. Whether there was cloudy or not, there was light throughout the day, and then there's darkness. So that's why the circadian rhythms take the strongest cue from our environment by tracking when it is light and darkness. And the best organ in our body that senses this light is the eyes. So that's why the idea is if we can connect part of the brain straight to the eye, then and put the circadian clock there, then that would act as the master circadian clock because it can sense light from outside and then control physiology. So that's why we have what is called suprachiasmatic nucleus, which is a small brain part that's almost at the base of our brain, consisting of only 20,000 neurons that's smaller than the tip of a pinhead. And those neurons are directly connected to the eyes through a special type of light receptors, blue light receptors. And these SCN neurons control sleep-wake cycle and our hunger-satiety cycle. And they also secrete some neurotransmitters or brain chemicals that actually go and train or orchestrate rhythms in other parts of the body.
Depending on the time of the day, as the light is changing, that area of the brain, the SCN for short, is detecting that change in the environment, and then that is sending some type of signal, be it through nerves or through chemicals, that change our physiology based on those changes in the environment. And the purpose of that is to kind of prepare us physiologically for what we should be doing in the environment at that time of the day.
Well, the SCN actually checks mostly the onset of light. So that means when it is the first ray of light that we receive, and also the last one. Throughout the day, it's not that sensitive to changes in the light intensity, but I would come back to you because there are other parts of the brain that actually sense light intensity and then they change mood, etc. So SCN, again, the same set of blue light sensors that send information to the SCN, they have a second or third job. That is, they also send information to other parts of the brain that regulate alertness, sleepiness, etc. So you're right. SCN, the same light sensors are sensing changes in the light intensity throughout the day, but SCN's job is just to check timing. And you mentioned another thing that yes, SCN actually does mostly three major things. Controlling sleep-wake cycle is a big thing. And then controlling body temperature. Our body temperature goes through 1 degree rhythm. And hunger, satiety. Those are the three. And then SCN is part of the hypothalamus, of base of the brain, that also connects to adrenal gland, pituitary and adrenal gland, or pituitary and gonadal axis. So in that way, SCN controls a lot of hormones that are involved in metabolism and also hormones involved in reproduction.
What's the relationship between the SCN, this central clock, and the peripheral clocks, if any at all?
Yeah, so when we say peripheral clocks, what we almost 20, 25 years ago, scientists figured out that there is not only one master clock in the brain. Actually, clocks are present in every cell, in every organ, even on our skin, even in the hair follicle. Everything has clocks. And that became a little complicated, because then the question is, what is the role of the SCN clock and what is the role of these local clocks? And then it became very clear that the SCN clock acts as the master clock, just like we have an atomic clock that tells all over the world what time it is, and then we adjust our local clocks. So similarly, the SCN clock is kind of the master clock, but all the local clocks in our liver, in our gut, heart, etc., they also sense what's going on locally, and they adjust physiology, metabolism accordingly. And the good example is, for example, as I told you, light resets or entrance our SCN clock. But when it comes to liver, although liver is getting some input from the SCN, if we eat at the wrong time when we're not supposed to eat, then the liver clock has to respond, say, maybe tomorrow food will come at 10 o'clock in the morning instead of 8 a.m. breakfast. So I got to readjust my local clock. So that's the role of these local clocks. They kind of try to readjust based on what's going on with our food, exercise, or other factors other than the light dark cycle.
When you say everything has clocks, can you take us inside a cell here for a moment at a basic sort of physiology, biology level? Where do these circadian rhythms or these clocks within the cell, where do they lie? Like what would we see if we're looking at the part of the cell that's actually controlling this and is essentially giving that cell information as to what it should be doing at a certain time of the day?
Yeah, so this is so right now we are going into the core molecular biology or genes, proteins, that level. And then the concept I'm going to tell you, that's the work of almost dozens of scientists over 30 years, starting from 1971 until 2000. So before 1970, people didn't think that there are clocks inside a body that tell us what to do at what time of the day. So scientists began with making mutations. So that means they would irradiate or they would make some mutant fruit flies, mutant mice, etc. And then these mice or these fruit flies have wrong sense of time. And then it took a lot of work to figure out what is wrong with their clocks, and that led to the discovery of this mechanism. So we all know that there are DNA that is present in every cell, and this DNA holds the blueprint of everything inside the cell, how much of protein is produced, how much of fat, how the mitochondrial energy production happens. Everything is encoded in this DNA. So similarly, there is a handful of genes, maximum 12 genes. So in our body, there are 20 to 30,000 genes, and out of these, only a dozen or so are involved in this time-keeping mechanism of clock. And there are two genes, and the name is actually clock, and then another one is female. So these two proteins, they do a very special work, just like nearly 1,000 other proteins. What they do is they go and find which genes have to be turned on, and then they bind to that DNA and then turn that gene on. So clock and female go and find certain genes and turn them on. And some of those genes are also called period. There is another protein or gene, and cryptochrome. Just let us take them as period and cry. So they turn these genes on, and then these genes, when they're turned on, they make proteins. Proteins are like enzymes. It's not the protein that we eat. Of course, the protein we eat is also similar to these proteins, but they have different function. So this cry and period par, as soon as they have made, they actually come back and tell, no, we don't want clock and female to work. We'll actually turn them off. And they come and turn them off. So this time between clock and female turning on cry and period protein, and then these proteins take some time to accumulate, and then they come back and turn off clock and female. So that entire cycle takes 24 hours. It's almost like, I don't know about specific country, but in the US, for example, in the freezer, we have an ice maker. And you turn on the ice maker, the ice keeps building, and then once the ice level comes to a high level, it turns off the ice making mechanism. And then you take the ice out of the ice maker, and when you take the ice out, then the ice maker begin to build up again. So similarly, this cryptochrome and PAR proteins, as their levels go up and up and up, they turn off they inhibit, in technical term, what clock and people do. But fortunately, there are other proteins that come and chew off this clock and beep, the pour and cry, which is almost like you taking out the ice cubes from the ice maker, and then clock and beep will come back and make. So this cycle takes roughly 24 hours. And since these proteins, they do have, this is not their only job, because clock people can also turn on thousands of other proteins. And so this cycle is connected to regulation of thousands of other genes, other protein. So as a result, there is a wave of genes turning on, and then there is another wave of genes turning off. So all of these work together to make this 24 hours clock.
What happens when that becomes dysregulated, where these genes are not being turned on and turned off at the appropriate time? I think last episode you described that as circadian disruption. So perhaps we could double click on what circadian disruption is. And I believe from last time you kind of spoke about jet lag being a very common sort of overt example of this.
Yeah, so when we say circadian disruption, when we talk about genes, usually we think that there are mutations, or there are people who have an altered copy of gene that disrupts the process, which to some extent is true. There are very few people, minuscule compared to, one in 100,000 or a million, something like that. They may not have a functional clock. But what is interesting is these clocks, as I mentioned, have to adapt, have to actually work in concert with the light-dark cycle, or when we eat and don't eat. Because although I said that this clock, BMAL, and all these proteins are working nicely, there are other factors that interact with these clock proteins. And those factors are sensitive to our hormone level, or how much heme, for example, how much hemoglobin we have, or how much sugar we eaten. So they're kind of sensitive to food, temperature, and what we say redox state, or how much of hemoglobin we have, for example, or heme-like compounds we have in our blood. So then what happens is, as you mentioned nicely, jet lag, when we're flying to a different time zone, suppose 3 hours difference in time zone. So that means in the morning when we wake up, although we woke up to an alarm clock, our SCN clock has not woken up, because it's a very slow 24 hours process. It's not like you can come and reset it like a digital clock. It will reset. It takes its own time to reset to the new time zone. And on an average, it takes almost a day to adjust to 1 hour change in time. So that means if you're flying 3 time zones, it takes 3 hours. So then you can imagine, we all can experience how that misalignment is, because our body is in, for example, I'm in California, and I flew to New York. And although I reached New York, my circadian clock, my CN clock, is still tracking California time. So as a result, in the morning, it's very difficult for me to wake up at local time, because New York 8 o'clock is my 5 a.m. in California. And after I wake up, then everything in my body is anticipating California time, California breakfast time, California lunch or dinner time, but I am in New York. So that misalignment causes what we call jet lag. So similarly, even if I am in California, suppose say one day I decided that, okay, I will wake up a little early and then come and talk to Simon. So in those days, I wake up 2 hours. I didn't actually wake up 2 hours early, but I'm just making this up.
Well, if you did, I appreciate the commitment. We all do.
So that's exactly happens, that you wake up in response to a alarm clock because you have to go somewhere, say catch a flight or go to work, or you have to take a call, and your body is not ready. And then for the entire day, you'll feel grumpy or crappy, you're trying to drink too much caffeine in the morning, because there is a misalignment, there is a mismatch between what your body is telling, what time it is, what you should be doing, when you should be having breakfast, when you should be waking up. And so that's called the circadian misalignment or circadian disruption. And when it goes on, so one day is not a big deal, you'll feel a little discomfort. But when it continues for many days, many months, as happens among shift workers, or as happens among new parents who have a baby, they're waking up too many times at nighttime, then that can lead to increased risk for many diseases. And we'll get to why that and how that happens.
I'm in London at the moment, and last week I was in Boston, and about 4 days before that I was in Los Angeles. So I'm experiencing a little bit of this jet lag now as we speak. And if my maths are correct, I think it's an 8-hour time difference between Los Angeles and here in London. So it could take me 8 days to get over this. Eventually, though, we do adapt to the new time zone. So what are the learnings that we have from studying jet lag and the insight from that, and how can that help us in sort of understanding and reducing this more chronic, insidious circadian disruption that can occur in our sort of day-to-day, everyday life?
Yeah, so what is interesting for almost 75 years of research was there are many mice that are blind. That means they cannot see the outside world. And yet, if we do jet lag, similar jet lag, we are not flying mice from here to London, but we can change the light-dark cycle in which they live. Then those mice, just like humans, they will also take 8 to 9 days to adjust to an 8 hours phase shift or change in light-dark cycle. That was kind of very interesting because these mice cannot see. There is light. They cannot sense, they cannot see anything. So that means we thought that they cannot also sense light. But what is interesting is if for some reason mice got into a fight, they fought with each other and supposedly they lost both eyes, then those mice, those who don't have eyes, then they cannot reset their clock to new light-dark cycle. They actually cannot even entrain their clock to just normal light-dark cycle because our mouse clock runs at 23 hours, 45 minutes. Human clocks, we run at roughly 24 hours, 15 minutes. So that means every day we have to adjust. So that was there for a long time, and people are trying to figure out, well, these mice cannot see and they're blind, but they can reset their clock. So in 2001, 3 different groups, including at that time I was a postdoc, we discovered that a specific type of light receptor called melanopsin, which senses light in the blue spectrum, can sense light and can reset this SCN clock. And these blue light sensors are very different from the rod and cone cells that we use to see our visual world. So during the daytime, when we look at a scene or anything that we do, we're using roughly millions of rod and cone cells to navigate. But these blue light sensors are present only in 5,000 cells. And those cells don't die when mice become blind, or in many human disease that leads to blindness, they don't die. They are there. So that explains why many blind people and blind mice, for example, those who have intact eyes, but they cannot see, they can reset. So now how can we use that information? So the point that this melanopsin is sensitive to blue spectrum of light, and at the same time, it actually needs a higher level of light. Just dim blue light will not do it. It needs a little bit of bright light. So that means when you are having jet lag, for example, Simon, when you flew from New York to London, then the next morning, if you're exposed to more blue light in the morning, particularly because SCN is most sensitive in the morning and evening, then we can reset our clock little bit faster. So that's why morning light exposure is very important. Now the question is, how do you get blue light? You're not going to go around walking with a blue LED light and shine into your eyes. Of course, there are some commercial products that deliver a little bit of blue light into the eye, and that seems to be effective. But the daylight, even if it's cloudy day in London, there is enough light in that diffuse daylight that's coming through the cloud to reset, to entrain our clock. So the point is, in the morning, just getting out, particularly when you are flying into a new time zone, then it's very effective. Even I do it. I wake up and the first thing that I do is go for a walk or go for just a slow jog outdoor for 30 minutes to 45 minutes. And that activity, physical activity, along with this light, just increase my energy level, and I can readjust to the new time zone much faster.
This episode is proudly brought to you by Inside Tracker. Track your blood biomarkers, understand your biological age, and receive personalized lifestyle tips backed by evidence to optimize your health. To get started with Inside Tracker today and get 20% off your first purchase, head to insidetracker.com/Simon. That's insidetracker.com/Simon for 20% off.
If you have the option, if you're booking a flight and you're jumping across 4 or 5 time zones and you can land in the daytime or in the first half of the day, or you can land in the evening when it's dark, what would you choose?
Light is only part of the story. The other part is food, because many years ago, scientists figured out that, including my lab, figured out that when we eat is a very strong timing cue for peripheral clock. That means our liver, our gut, lungs, everything is tracking when we eat. Even if there is light dark cycle, if we eat at the wrong time, then our liver clock, our gut clock, all of these clocks in the rest of our body will take timing cue from when we eat. So in that context, what is becoming more and more important is it's both the light and food that are important. So it doesn't matter what time of the day your plane lands. If you adjust your eating time, after you land, there is again 24 hours in the new time zone when you have to adjust our eating, fasting, and light exposure and darkness. So what becomes important is minding both food and light. In terms of choosing your flight, of course, for a lot of us who depend on commercial flight, who don't have a private jet, then the choices are very limited, because the bottom line is all the flights from US to Europe, they leave in the afternoon or afternoon or evening from US so that they reach Europe in the morning. And this is almost, you can look up almost all flights. They will reach Europe in the morning. So in that way, the only thing you should be doing in flight is sleep, because you're not supposed to eat. It's a short flight, 8 hours or maximum 10 hours from LA or San Francisco. And then when you reach in the morning, just go outside, and by the time you reach your hotel, you get good exposure to light, and then have a good breakfast. That resets the clock.
So as quickly as possible, you basically want to be adopting the behaviors of the people that are already living in that new time zone that you've gone to.
Yes.
Okay. Providing that they're living a healthy lifestyle. The blue light receptors, this blue spectrum of light that you're talking about, makes me think about blue light blockers. So how sensitive are these receptors to, say, blue light that comes from screens and devices? And if we're, let's say it's 8, 9 p.m. at nighttime, outside it's dark, but we're sitting inside on our laptop or using an iPad, is the blue light that's coming, is there blue light coming from these devices, and is it sufficient enough to disrupt these circadian rhythms?
Yeah, so blue light sensors, these melanopsin blue light sensors, they actually send their projections. So that means their connections to different parts of the brain. Although SCN exclusively receives input from these melanopsin or blue light sensing cells, there are other parts of the brain that are involved in sleep-wake cycle regulation or alertness, and also in indirectly production of melatonin at night, the sleep hormone melatonin. So if we look back, before we had electrical lighting, the only light source was candles, kerosene lamp, gas lamp, etc., and firelight. And those lights, those sources of light have very little blue light, so that's why those lights look orange color. And in the modern days, as you pointed out, all these rectangular pieces of glowing objects, or screens and tablets and phones, they do have good amount of blue light, particularly when you crank up the brightness to more than 50% brightness. And a lot of us, we forget, we keep the phones at 75 to 100% brightness. And that does two things. One is just the emotional aspect. You are not just staring at a blank screen. There are contents coming through, and that can affect our emotions, whether it's happy, sad, stressful. So that's one aspect that we often forget. And no blue light blocker can block that aspect. So let's put it that way. And then the second is, yes, there is blue light. So then the question is that enough? Yes, scientists have done these studies and finding that if your phone, if your tablet is at full brightness or even 75% brightness, then that is enough to reduce significantly nightly rise of melatonin. So that means we may not have high level of melatonin to make us feel sleepy when we're supposed to sleep. And this is becoming more important even for kids because these days kids are given a phone or a tablet to keep them entertained. So their melatonin levels also don't go up enough. And at the same time, light is making them more alert. So that means they are cranky. So that's also another problem. So the bottom line is, yes, it does impact. And one way is to use the night shift or night light feature in all your devices. And if possible, you can also try a pair of blue blocking glasses. But then the best blue blocking glasses, the ones that are effective, are also kind of little weird looking because they either look yellow or a little bit tinge of red.
Well, I guess it depends on how important one's sleep is and how disrupted these rhythms are. That's interesting about the emotional piece there, and the blue light blockers not being helpful for our emotional response to our devices. Perhaps we need some type of all light blocker, or maybe that's called a blindfold, or just get off the devices at nighttime, especially if they're triggering us. In the last episode, Satchin, I think you mentioned the criteria for circadian disruption. There was a definition of that, and I think you said being awake for 2 or 3 hours per night between 10 p.m. to 5 a.m. for 50 days or more per year, which works out to be about one night per week on average. You're up for this 2 or 3 hour period between 10 p.m. and 5 a.m. What percentage of people in Western countries do you think would meet that criteria?
I would say almost everybody in their lifetime meets this criteria for a few years. So let's start with the middle school, high school students, particularly high school students. They easily stay up till midnight. And they're working on their homework, or in many cases in the US, for example, they have evening activities, going for soccer practice or baseball practice, etc. And then they're coming back and working on their homework or doing something. So they would meet the criteria of shift work. And then the same thing happens with college students. So if you are educated, if you went to high school and college, you are spending almost at least 4 to 8 years of your life working, living the lifestyle of shift workers. Then almost every new mother is living the lifestyle of a shift worker. Actually, worse than that, because shift workers actually get days off, but new moms don't get days off. So they live this lifestyle for at least a year. And then if we think about everybody else, if you're socializing for at least one night in a week, and that socializing involves going to a pub or going to somewhere and staying up till midnight, or if you're the one closing the bar, then let's put it that way, then you are a shift worker too.
Right. And then there's a pretty high percentage of essential workers that are doing the shift work as well.
Yeah. So 1 in 5 worker is a shift worker. And those are the card-carrying shift workers. They don't include, say, your Uber driver or gig workers. And we know that gig work, food delivery work, and all this gig works also involve a lot of nighttime work, but they are not counted technically as shift workers. And this other thing is second-hand shift workers. So family members of shift workers, they are also disrupted. Their lifestyle is disrupted because they want to be extra caring. They want to care for the person who is doing the shift work. So they are also affected. So roughly, I would say 75 to 80% of adults experience the lifestyle of a shift worker for a few years in their lifetime.
What do you think about people that don't maybe fit into those boxes, but are just eating at highly variable times? They're not going to bed at consistent times. How sensitive are these circadian rhythms, and resilient are they in terms of, I guess, doing what they're meant to do across the day?
Yeah, I guess sleep is a very good reference point because we all experience it. So a lot of people would say, means if you're going to bed at a consistent time, so that means plus or minus, say, 30 minutes. So suppose say I go to bed between 10 and 11 most nights, then I'm okay. But then if 1 or 2 nights in a week I'm watching TV and binge watching some shows that I missed and staying awake till midnight or 1 o'clock, then I know that next day will not be normal. So that's a sign that my circadian rhythm got disrupted. And the question is, what do you value? So for example, a lot of us, we want to feel at our peak performance, physical, emotional, intellectual performance every single day. We don't want a crappy day. We don't want a slow day. So for in that perspective, yes, we actually wasted one day because of our bad habit the previous night. But if that is not important to you, maybe you might not value it that much, but then when it continues for several weeks at a time, then that can trigger some underlying condition. It's almost like you take your pickup truck off-roading instead of smooth road, you're going off-road. Going once or twice is not bad, but if you go too frequently, then you will damage your pickup truck or your car. So the same thing happens in terms of circadian rhythm. So people would say, well, one night of late night eating may not damage my body, but if you do it again and again every week, even once a week, if you're eating too late into the night, then slowly that will catch up, and you may experience some underlying conditions that you're susceptible to, whether it's acid reflux, whether it's indigestion, or whether it's some autoimmune disease that flares up. So those are the things that are more likely to happen if we have circadian disruption like this.
If we think about timing of food for a moment here, in relative terms. So imagine we have two scenarios. We have, and I appreciate this is not an either or question, but I'm going to put you on the spot here. we have scenario A where this person eats at the perfect time of the day. He takes Satchin Panda's protocol and he does it every single day perfectly for 365 days a year. But his diet quality is really poor. He's not eating the foods that we would say are typical of a health promoting diet. And then person B, he says, screw Satchin Panda's protocol. I'm going to eat sporadically, different hours, all hours of the day, but I'm going to focus on diet quality. And he absolutely nails that for 365 days, he or she, I should say, for 365 days a year. Which one do you think is sort of more impactful when it comes to our health?
The underlying question is this: having a strong circadian rhythm, is that giving you resilience to withstand the bad effect of unhealthy diet? And then the second is healthy diet gives you the resilience to overcome the bad effect of circadian disruption. And this is where what you're looking for becomes important. So, for example, I would say, so we haven't defined what is the unhealthy diet, the first scenario, because if it is just regular American diet, we're not talking about excessive, we're not talking about excessive alcohol or anything. It's just regular American diet. You are not eating every single meal in a cheeseburger or something, but makes just average person. I would say the first one would have better resilience against many conditions. The reason is this. And the second scenario, for example, this person is eating healthy diet, but maybe waking up in the middle of the night, is a little bit hungry, eats something, goes back to sleep. So what would happen is the gut, the digestive system will get affected the most, because the digestive system, the digestive lining, needs to repair itself every night. And when you eat randomly at any time of the day or night, then that repair mechanism is disrupted. So it's almost like we have two scenarios. One where the highway is heavily used, big trucks are running, but the highway maintenance is much better. And the question is, in the long run, whether this highway will remain healthy or not. And then the second one is where the traffic is very light, but the highway is never maintained. There is no road repair. Then what will happen? It's almost like your side street in your neighborhood, where the traffic is not that bad. It's very light traffic, very slow traffic, safe traffic, but the roads are not repaired. Is it going to be staying well? So in that scenario, I would say that if you're eating an average Western diet, but doing time ratio eating, that may remain in long term, the resilience will be much better than you're eating all the right thing, but eating at least 2 or 3 times late night or middle of the night, you're waking up and eating.
I like that analogy. And I guess what we really want is light traffic and plenty of repair. So we have the best of both worlds. But thank you for answering that. I appreciate it. I put you on the spot there. So before you kind of mentioned that if we want to feel at our peak in our day-to-day, then we want to be nurturing these circadian rhythms, and we want these rhythms in sync with our environment. Just to kind of connect the dots a little bit more for people, and you just spoke to what can happen in the gut. But if you were to look under the microscope, as someone who's experiencing circadian disruption, whether that is a shift worker or it's this person that's staying up all night and watching TV and waking up at different times, if you were to kind of zoom in, what kind of things would you see from a physiology point of view that are different to someone who is really nurturing these circadian rhythms?
We have looked at many of these in animals, because we can actually open up and look under the hood. And what we see is wide range of disruptions. One is Everything that we eat is not nutritious. So, for example, there are many xenobiotics or unwanted chemicals, whether it's benign food flavoring agents or natural flavor or color of the food to many other things that are in the food that we eat that are not good for our body. So we have to break them down by the specific set of proteins, enzymes called cytochrome P450s. And what we find is even in mice that are eating randomly a healthy food, they don't crank up the expression or the levels of this toxin breaking down enzymes, cytochrome P450, to high enough. So, one thing that might happen and that we do see happening is these enzymes that break down toxins, they also have another essential job, that is to break down cholesterol to bile acids and breaking down cholesterol from many other types of hormones that our body needs. So those things don't happen efficiently. So as a result, slowly our cholesterol levels can build up above what our body requires. And also we reduce the amount of other cholesterol byproducts that are essential to our body. So that's one example. Then the other example is our kidney is part of a very complicated system to maintain blood pressure. And that blood pressure regulation also doesn't work properly, particularly if the food is slightly higher in salt. And we know that in Western diet, we consume slightly more salt than what our body needs. So in these instances, then our kidney is disrupted, this blood pressure regulating system is disrupted, and our blood pressure can, over time, can increase. So similarly, we find disruptions in almost every organ. Recently we published a paper where we looked at 22 different organs and brain regions from mice that are eating kind of a Western diet ad libitum whenever they want or under time restricted feeding. The goal was to see what is going on. And we find in every organ there are this organ specific disruption. And also there are some general disruptions that are happening everywhere. So one is, for example, DNA damage repair. Almost every day we damage a little bit of our DNA, and that needs to be repaired, because if we don't repair that DNA, then that can, over time, become the source of tumors and cancer. And so that DNA damage repair pathway gets disrupted. So it doesn't mean that just few days of eating randomly at nighttime will cause cancer. But what it does is it increases our risk for cancer. So conversely, we have seen that mice that eat time-restricted feeding, they have low risk of cancer. And even if we put tumors into the mice, then those tumors don't grow as well, don't grow quickly in mice that eat time-restricted feeding. So that's very clear example that what we see in gene expression signature is relevant. Similarly, there are a lot of proteins that are misfolded. So that means when we make proteins, they have to be shaped up into different shape. It's almost like a 3D printing tool that we have in every cell in our body. Is the same plastic, is the same amino acids, but they are shaped into different forms so that they can do different things. So that 3D printing machinery of protein folding gets disrupted. So the consequence is we may have accumulation of misfolded protein. So one example is many neurodegenerative disease. For example, Alzheimer's disease and many other diseases that affect our memory, those are misfolded protein disease. And we do see that even in mice, Alzheimer's disease mice model, or mice that have those kind of dementia, if we put them on time restricting so that their circadian rhythm is much better, then misfolding is likely reduced because their disease severity is less. So the bottom line is we see many things that are very fundamental to every cell, health of every cell, that is reduced under ad libitum or random eating condition.
When we think about chronic diseases, I guess the typical risk factors that come up that are shared by many of these diseases are things like cholesterol or blood glucose control, insulin resistance, hypertension, the typical risk factors, BMI or obesity, inflammation, etc. Based on the animal research and human observational data and our understanding of circadian disruption, do you have a sense for what sort of percentage contribution circadian disruption would have to the incidence of these chronic diseases that we're seeing? How much of a role is circadian disruption playing, do you feel, in diseases like type 2 diabetes or non-alcoholic fatty liver disease or various cancers?
It's really hard to pinpoint that because of two reasons. One is whether circadian disruption directly is contributing to the disease or circadian disruption is facilitating other bad habits. Those in turn contribute to the disease. For example, when we eat late into the night, we are not eating a bowl of salad at 11 o'clock at night. What you're more likely eating or drinking is more alcohol late at night and all the fatty or salty or sugary food that goes late into the night. So in this way, the eating habit late at night may be disrupting circadian rhythm, but there is kind of a double whammy because what we're eating is also not good, which can contribute to various metabolic disease. So what we see, for example, when people do time-restricted eating and then they stop their food, say at 7 or 8 in the evening, we do see a significant reduction in alcohol intake. So now the next question is, well, if the alcohol intake is going down and if we see improvement in emotional and brain health, how much of that is due to circadian consolidation versus reduction in alcohol consumption? And then the answer is both. Because those who are not drinking, their mental health is also improving, and there we cannot ascribe it to alcohol. Whereas those who were drinking, there we can ascribe some of it to alcohol. The same thing. So I would say that circadian disruption does two things. One, circadian disruption, eating late at night, sleeping less, all of these contribute to some extent to hypertension, type 2 diabetes, insulin resistance, because in animal models, when we do time-restricted feeding and allow the mice 12 hours of darkness, 12 hours of light, for example, then without changing quality of diet, without changing quantity of diet, we can, and we do see, we can prevent and reverse many aspects of chronic metabolic disease. And also we can reduce, just like I mentioned, we can reduce the severity of neurodegenerative disease, dementia. We can also reduce the severity of cancer. We can also reduce the incidence of cancer in mouse model. So that's without changing quality, quantity of diet. Whereas in humans, the result is, yes, we do see in many cases, for example, we have taken it for granted that unless you lose weight, you cannot improve blood pressure. Unless you lose weight, you cannot improve your insulin resistance. And it has come to a point that there is even a formula that you have to lose X percentage of body weight to see this much improvement in blood pressure or blood sugar. But what is exciting in time-restricted feeding or intermittent fasting kind of studies is we do see the benefit even before people lose weight or with very minimal weight loss. So that means the improvement is not directly tied to weight loss, but to potential improvement in circadian rhythm. So in that way, I would say almost everybody who has one of these conditions, hypertension, for example, almost more than half of the adults in the Western world have hypertension. At least in the US, they have hypertension. Or pre-diabetes or diabetes. Almost half of the adults in the US now have pre-diabetes or diabetes. And then high cholesterol. I guess the formula now is as soon as you reach 40, don't even think about it. You should get on statin. It's because it's so. So I guess all of us can benefit by reducing the severity of these conditions, and in some cases even getting rid of a low dose medication if you're on, by following a strong circadian rhythm lifestyle that includes both sleep and time ratio eating.
Hey friends, if you'd like to stay connected and reinforce the valuable insights from this show, let's connect on Instagram. You can find me at Simon Hill. That's at Simon Hill. I look forward to seeing you there. All right, let's dive back into the episode.
I was going to ask you this later, but I may as well drop it in now. I sent you a news study. It was in the Annals of Internal Medicine, that randomized controlled trial. Did you see that?
Yeah.
That recently came out. It was looking at a 25% calorie restriction versus time restricted eating, like an 8-hour window from midday to 8 p.m. And this was in subjects with obesity. They found that both of those interventions resulted in weight loss over the 6-month period. And all those subjects were also getting one-on-one, I believe, counseling from a dietitian to focus on food quality. They lost about 4 or 5 kilograms of weight in the 6 months in both groups, whether they were doing calorie restriction or if they were just simply shortening their eating window to an 8-hour window from midday. I was interested in, they also measured some metabolic outcomes, and they didn't report any significant differences between those outcomes. And I'm aware of Courtney Peterson's work. She's been on the show previously and spoke about one study she did in folks with pre-diabetes where they did in fact see improved blood glucose control in the time-restricted group independent of weight loss, which was what you were just kind of talking about before. Were you, I'm not sure whether you've looked at this new paper in detail or not yet, but were you surprised that there, despite the weight loss being the same in the two groups, the group that restricted their eating hours to 8 hours per day didn't have any sort of significant differences in terms of those metabolic outcomes?
Well, it depends on whether they actually had the metabolic defects to begin with, because the problem is in many of these studies on time ratio eating, people are recruiting relatively healthy, overweight or healthy obese patients. So that means they already are beginning with relatively healthy level of blood sugar, blood pressure, blood cholesterol. So then you won't see much difference because there is not much headspace to change. And that's why what is important is to look for studies which are extremely rare, where people actually start with diagnosed disease, who are on medication or who already have pretty high blood pressure, blood sugar, or blood cholesterol. In those cases, and this is where we did a study with Dr. Pam Top, because those studies require physicians' active guidance and active supervision, and which is not easy because in many of these other time ratio eating studies, essentially they're told, okay, here is your noon to 8 p.m. Go ahead. We'll see you in 3 months. And sometimes they're also not followed up. For example, I would suspect almost all caloric restriction studies, I don't know how much actual calorie reduction they achieve, because we have seen, and not we, I mean the scientific community has seen that Calorie-2, which is a very famous 2-year calorie restriction study, where the target was to reduce calorie by 25%, they achieved only 12 to 15% calorie reduction. Because when they rigorously looked at what people are eating and how much they were eating, they figured out that although the advice was 25%, people actually ended up reducing their calories by 12 to 15%. Similarly, in many of the studies, where particularly when it's 8 hours, I have serious doubt whether these people actually did 8 hours, because we have seen in our studies, we put a CGM, we asked them to use a My Circadian Clock app. And even though you ask them to eat within 8 hours, we do have social obligations. We do have work that conflicts with our lifestyle. So we tend to see that they drift towards 10 hours. And particularly when you impose that you have to eat between noon and 8 p.m., I'm extremely doubtful that people actually, every single day, they're eating between noon and 8 p.m. So we have to keep those in mind, that how much compliance, how much adherence is there that is objectively collected from these patients. So these are the two caveats, that we don't know how much of compliance adherence was there. And second, since these people began with relatively healthy level of blood pressure, blood cholesterol, blood sugar, and there might be variability within the group, we may not see differences between groups.
Yeah, I guess some of that speaks to the real world application of different interventions. I think in this paper, they reported adherence, and it was about 1/3 of the group in the calorie restriction couldn't adhere to calorie restriction well. And it was a fair percentage of the people in the 8-hour window that also didn't adhere. But to get the metabolic benefits that you're speaking about, that you believe can be independent of weight loss. So would I be right in if I was to summarize everything you just said then, that one, the baseline health of the person matters. So the poorer your metabolic health is, perhaps the bigger benefits that are up for grabs here with restricting the eating window. And then secondly, the eating window, the size of that eating window will matter both from a adherence point of view, but also from an effectiveness point of view. Would you say the tighter the window, the more effective it would be, but it would be probably you'd see poorer adherence?
I guess so. That's why most of the studies that we do, we actually do 10-hour time ratio eating. We ask people to adhere to a 10-hour, because what we find is even if you start with 8 hours, they're drifting towards 10 hours. And so 10 hours is more doable over long term. And second is we ask people to do a self-selected 10-hour time window. We don't ask people to look at the clock, wall clock, and say, yes, it's noon, start eating, or yes, it's 8 p.m., stop eating. We ask people to incorporate some of the other principles of circadian rhythm that actually helps them to adhere to this and also get more benefit. And for example, we know that as soon as we get up, at least for an hour or two, is not the best time to eat, because our blood sugar regulation mechanism is not primed for us to eat. Similarly, 2 to 3 hours before going to bed, our metabolism is also not at its prime. We cannot digest and assimilate food properly. So we ask people to incorporate those aspects. We also ask people to see whether they're sleeping enough, because if you don't sleep enough, then it becomes difficult to, emotionally, it becomes difficult to adhere to any discipline. So all of these matter. So in that case, what we find is, yes, in those cases, when people self-select a 10-hour window, they are more likely to adhere to. And in that case, we do see benefit. And as you pointed out, the bigger I won't say that for example, if someone's cholesterol is extremely high, in that case, of course, that person needs to be under cholesterol reducing drugs. But at the same time, if he or she combines that with time restricting, then the benefit will be better.
So just help me understand something. So in that paper, you're thinking that maybe those people with obesity were a sort of metabolically healthy obesity phenotype. So does that mean that if there's someone listening and they are of a healthy body weight and markers of metabolic health are in the normal range, does that mean that for that person, how much they eat is more important than when they eat?
No, I guess here we are always missing one point, that is weight loss is not the only indicator of health. As I pointed out, there are 4 or 5 different major reasons why we don't live long enough. One is infectious disease, one is metabolic disease. And among metabolic diseases, again, the one thing that we can every day check is blood glucose or if you have a continuous glucose monitor, or weight, that we almost all of us have access to a scale, or at least we can see ourselves in the mirror. But we also have brain health issues and then recovery from injury and all of these that we're not talking about them because we haven't even done many of the experiments there. So coming back to somebody who has a healthy body weight, so between, say, BMI 22 and 25, then that person, yes, one has to pay attention to quality of diet and also how much they're eating, because if they're also physically active, they have to take into account how much physical activity they have, whether they're eating enough, because too much physical activity and less food is also not good for our body in long term. But that's where one thing becomes important, that if you have too much physical activity, suppose say you're bodybuilding or you're training for marathon, then it becomes very difficult to eat enough food within a very short window of, say, 4 hours or 6 hours, because I hear sometimes people are trying to do 1 meal a day or 4 hours of eating or 6 hours of eating. That may not be enough window to cram enough calories if you are training for marathon or training if you're an athlete. So in those cases, 10 hours or even 12 hours of eating a healthy diet is much better than eating less food within a short window.
Satchin, I think this is the perfect place to land the plane for today as part one of this continued discussion on all things circadian rhythms and health. And then in part two, we can cover the 6 simple habits to nurture our circadian rhythms that you and I have been chatting about over email. There you have it, friends. I hope you enjoyed this episode. If you did and want to stay up to date with future episodes, be sure to hit that subscribe button on YouTube and follow on Apple or Spotify. Finally, thank you for showing up and the effort that you're making to take control of your health. I look forward to hanging out with you again in the next episode.